Hello. In this mini lecture, I will introduce a formal definition of Boolean algebra. So, Boolean algebra is the topic. In the first classroom lecture, I was using a two-element Boolean algebra, which was derived informally from sentence or prepositional calculus. Okay, as you remember, this was the operands in this algebra was conjunction and disjunction and negation of the sentence of the preposition. Okay, three operators. It was two binary operators and one unary operator. Okay, it was two-element algebra, but the definition is more general, and Boolean not necessarily means two-element, because the definition is the algebra structure consists of B as the set of elements, not necessarily two or more elements. So Boolean algebra of any number of elements can be constructed, can be found. And three operators, but now I will be using the symbols which come from our common algebra, everyday algebra. Yes, these are this is new. It is a complement. It refers to is almost the same as, it is not true then in the sentence calculus, but in this definition I will call it complement operator. And B is a set of two or more elements. In the slides 22, 24, 25, 26. In my lecture material, I present this algebra and also an example of B, which consists of, instead of 0, 1, different set of numbers. 1, 2, 3, 6. So it is possible to have more than two elements in Boolean algebra. And what is important is that these are names. A standard name for this will be, independently of how you define it, actually, it will be named logic sum or logical sum, logical addition, not arithmetic addition, but logical addition. And this is conjunction, which will be named logical multiplication or product, and the name of operation is multiplication. Okay, and the third operand, as I said, it is a complement. Okay. So one example was the logical sum was the conjunction, logical product, disjunction, logical product, conjunction, and complement was the not true then operator. And what is more important are the axioms. There are 4 axioms for this algebra. You must select such logical sum operation and product and complement to be in order the following axioms will be satisfied. So the first is commutativity. You know it already from our common algebra. It is a very simple. It says that A plus B, whatever plus is actually, must be equal to B plus A. So the order is unimportant when you perform the operation. The result will be the same. And for the same for logical product, so A times B must be equal to B times A. In our algebra it is satisfied, so it is Very simple to memorize for you, okay? So it is your task to memorize all of the axioms and theorem I will present in this mini lecture, okay? There are more theorems than I will present, but you must know only these slides 22, 24 and 25 in my materials. So the second that I choose is the distributivity, Distributivity, you know it as well. A plus B times C, so times mean product, okay, equals A plus B times, okay, I am using the names, sorry, which come from our algebra, and also the counterpart. So A times B plus C. This is not very common. Yes, it is a new. Yes, it is a different than in our algebra. You must pay attention on this. And this, I hope you can do it. It is simply A times B plus A times C, factorizing out. Yes, factorizing. These are two axioms, and the third axiom is what introduces axiom A3 is identity elements. There must be two of them. One is the identity element for addition. It is denoted by 0. Okay, and so if you add something to 0, you get the same element. Okay, and if you multiply something by 1, and 1 is a name, it is not the value, it is not the number, it is a name, 1 and 0, or I and E in mathematics, is equal to A. So it is identity elements. So 0 and 1 must be two of elements in the Boolean algebra. They must be different, and the features are the following. Okay, they don't change. 0 addition and 1 doesn't change multiplication result. And the last one is the A4, it complement. It introduces what the complement operation is. Okay, it is such an operation that the following axioms must be satisfied or are satisfied. So A plus not A, it is a complement of the A. This sum must be equal to identity element for multiplication, not for addition, for multiplication. And the opposite. So A times not A must be identity element for addition. And that's all. Axioms. I have finished this, and then you've got a set of theorems you must memorize as well. And the first is A plus 1. Let's say A plus 1. 1 is also S, the name in general. In our two-element algebra, which comes from propositional calculus with disjunction and conjunction, of course, 1 will become 1 element, and 0 identity will become 0 value. So we will omit this quotation symbols later on. And for now, it is a formal one, so I will keep with. So this is the first, and the second is that A plus A equals not to A as in our algebra, but simply A. And if you double complement, you've got the same element, very similar to calculus operator, not true that. It is not true. And A plus A times B, okay, equals A simply. And A plus not A times B. Times means the logical multiplication. Equals A plus B. Then you've got also De Morgan's law, and I hope you remember from sentence calculus, A, B, and the last one is associativity, A plus B plus C. You can do it in any order, for example, in this way, plus B plus C. Okay. So in the slide in slide 25 in my lecture materials, you've got more theorems than I just presented, because there is always a symmetry. What I can derive for addition, I can also derive for multiplication. And in general, this rule is called duality, and this Boolean algebra I have just presented is dual. It means that in order to, you don't have to memorize all of the axioms and all of the theorems presented in the slides 24-25, but also half of them using the duality rule. The duality rule is, if you've got a theorem, you can perform such a substitution, and you will get the symmetrical theorem, which is also satisfied in Boolean algebra. I have omitted quotation marks, so now let's do this, and let's do an example. And let's start with axioms. Axioms can also be memorized only by half of them should be memorized. For example, if you've got A3, as you remember, there is X or A, doesn't matter, plus 0 equals X. Okay, and let's do the substitution. X, which plus is substituted by dot, that's a multiplication, 0 by 1, and equals X. You've got the second one. Okay, so memorize this and this simple rule, and you'll get this. A4, for example, X plus not X gives you 1, so having this rule in mind, X times not X equals 0, so 1 transformed to 0, and so on. Let's take one of the theorems, for example, A plus not A times B, okay, equals A plus B. If you make use of duality substitution, you've got something like this. Times, instead of plus, you've got dot here, and this must be left without any changes. Dot into plus, B without any changes, and must be equal to A plus is transformed to dot, so A times B. So you've got the second, okay, on the left hand side in slide 25, you've got this, and if you do this substitution, you make use of duality rules. Okay, so you got it. So only half of them must be memorized, and please do it. Don't only look, you must simply write down all the axioms and theorems I presented in my slide on paper, okay? Many times, until you'll be successful in writing down all of them without any errors, please, because it will be the first task in the laboratory entrance test, to write down all the axioms and theorem presented in the slides. Thank you.